Hello everyone. Today we start data structure, that is very important subject in computer science and engineering. And now I am Ashish Chore, assistant professor in computer science and engineering department, SIRT Bhopal. In today's topic, we cover the introduction of data structure, need of data structure, advantages of data structure classification, operations on data structure. In the introductory part, data structure can be defined as the group of data elements which provide an efficient way of storing and organizing data in the computer so that it can be used efficiently. Some example of data structure are array, linked list, stack, queue, etc. Data structure are widely used in almost every aspect of computer science. That is operating system, compiler design, artificial intelligence, machine learning, graphics, and many more. Data structure are the main part of many computer science algorithms as they enable the programmers to handle the data in an efficient way. It play a vital role enhancing the performance of a software or a program as a main function of the software is to store and retrieve the user's data as fast as possible. Second point is need of data structure. Why we need data structure? As applications are getting complexes and amount of data is increasing day by day, there may arise the following problem. Number one, processing speed. Number two, data search. Number three, multiple requests. In the processor speed, to handle very large amount of data, high speed processing is required, but the data is growing day by day to the billion of the files per entity. Assume this processor may fail to deal with that much amount of data. Second one is data search. Consider an inventory size of 106 item in the store. If our application need to search for the particular item, it need to traverse 106 item every time, result in showing down the search process. Number three, multiple requests. If thousands of users are searching the data simultaneously on a web server, then there are the chance that a very large server can be failed during that process. In order to solve the above problems, data structure are used. Data is organized to form a data structure in such a way that all items are not required to be searched and required data can be searched instantly. Now, what is the advantage of data structure? Number one, efficiency. Number two, reusability. And number three is abstraction. Now, in the efficiency of a program depends upon the choice of data structure. For example, suppose we have some data and we need to perform the search for the particular record. If in that case we organize our data in an array, we will have to search sequentially element by element. Hence, using array may not be very efficient here. There are better data structure which can be make the search process efficiently like order array, binary search tree or hash table. Now, the second advantage is reusability. Data structure are reusable. That is, once we have implemented a particular data structure, we can use it any other place. Implementation of data structure can be compiled into libraries which can be used by different clients. Third advantage is abstraction. Data structure is specified by the abstract data type. which provide a level of abstraction. The client program uses the data structure through interface only without getting into the implementation details. Okay. Now, data structure classification. This is the most important diagram. Always remember this diagram in the future. In that, data structure is two types: primitive data structure and non-primitive data structure. Here we just talk about the non-primitive data structure. In non-primitive data structure, there are also two types: linear and non-linear. In linear data structure, there is also two types: static and dynamic. In the static type, array, and in the dynamic type, linked list, stack, and queue. And in non-linear data structure, we learn tree and graph. Okay, so remember this diagram. This is the most important diagram. Now, linear data structure. What is linear data structure? We know the meaning of linear now, so just correlated here. A data structure is called linear if all its elements are arranged in the linear order. In linear data structure, the elements are stored in non-hierarchical way where each element has the successor and predecessor except the first and last element. Types of linear data structure are as follow. Number one is array. An array is a collection of similar type of data items, and each data item is called an element of the array. The data type of the element may be any valid data type like character, integer, float, or double. The elements of array share the same variable name, but each of one carry a different index number known as subscript. The array can be one dimensional, two-dimensional, or multi-dimensional. The individual element of array age are like this: age 0, age 1, age 2, age 3, like that. Okay, this is the example of array, how we show the array in linear way. Now next one is linked list. Linked list is a linear data structure which is used to maintain a list in the memory. It can be seen as the collection of nodes stored at non-contiguous memory locations. Each node of the linked list contains a pointer to its adjacent node. Okay, this is the example of linked list. Here the first one is 100 shows the head pointer holds the address of the first node. Okay, now in the list, the first part is data part and the second part is address part, and 100 is show the address of first data, that is data is 10, and 200 show the next address of memory. Okay, so this is the linear sequential. Now the next data structure is stack. Stack is a linear list in which insertion and deletions are allowed only at one end, called top. A stack is an abstract data type. ADT can be implemented in most of the programming languages. It is named as stack because it behaves like a real world stack. For example, piles of plates or deck of cards, etc. Okay, now this is the example of stack. In the stack there is two operations working: push and pop. Push for the inserting the element in the stack, and pop for deleting the element from the stack. Now the next data structure is queue. Queue is a linear list in which elements can be inserted only at one end, called the rear, and deleted only at the other end, called the front. It is an abstract data structure similar to stack. Queue is opened at both ends, therefore it follows the first in first out. Methodology for storing the data items. This is the example of Q. Now, the another part of data structure is nonlinear data structure. This data structure does not form a sequence, that is, each item or element is connected with two or more other items in a nonlinear arrangement. The data elements are not arranged in sequential structure. Types of nonlinear data structure as follow. Number one, tree. Tree are multi-level data structure, and tree is the most important data structure. And in the tree there is so many trees that questions in the for the examination purpose and the gate purpose and the other examples in the real world are very important. So tree is the very important data structure. Tree are multi-level data structure with a hierarchical relationship among its element known as nodes. The bottommost node in the hierarchy are called the leaf node, while the topmost node is called the root node. Each node contains a pointer to point adjacent node. Tree data structure is based on the parent-child relationship among the nodes. Each node in the tree can have more than one children except the leaf node, whereas each node can have at most one parent except the root node. Tree can be classified into many categories which will be discussed later. Okay, this is the example of tree. The P show the root value. Okay, and there is the leaf nodes like H, I, E, F, G, you know, and this is also show the parent-children relationship like P is the parent of Q, R, and P is a grandparent of A, B, C, D, like that. Okay, and in the tree so many subtrees are also possible. Now the next non-linear data structure is graph. Graph can be defined as the pictorial representation of the set of elements connected by the link known as edges. A graph is different from the tree in the sense that a graph can have cycle while the tree cannot have the one. This is also example of graph. There is a cycle A, C, D, B, and B or A also connected. So there is one cycle or another cycle is A, C, D, and A and D also connected. So this is the another cycle. So cycle is also possible in the graph sense. Now, operations on data structure. There is so many operations, but in important way we just cover some important operations. Number one is traversing. Every data structure contains a set of data elements. Traversing the data structure means visiting each element of the data structure in order to perform some specific operations like searching or sorting. Next operation is insertion. Insertion can be defined as the process of adding the element to the data structure at any location. Now, next operation is deletion. The process of removing an element from the data structure is called the deletion. Next operation is searching. The process of finding the location of an element within the data structure is called the searching. Next, sorting. The process of arranging the data structure in the specific order is known as sorting. There are many algorithms that can be used to perform sorting, for example, insertion sort, selection sort, merge sort, bubble sort, etc. Now, the next operation is merging. When two lists A and B of size m and n respectively of similar type of elements clubbed or joined to produce the third list size of C m plus n, then this process is called the merging. So these all are the introduction part or basic part of the data structure. In the our next lecture we start the depth knowledge of data structure day by day in the start from the array. Okay, so thank you guys for listening me.